This is on sequences. Sequences are beautiful because they're very intuitive. This is what you're used to thinking about. They come up every day in life. It says, find the first 4 and 100th term of the following sequences. So it says a sub 1. So if you write a sub 1, that means the first term. Well, how do we produce that? You take whatever n is. What is n in this case? 1, and you minus 5, and we get negative 4. So a sub 2 would be 2 minus 5, which would be negative 3. And a sub 3 would be 3 minus 5, which is negative 2. A sub 4 would be 4 minus 5, or negative 1. Can we produce the 100th term? Yeah, a sub 100 is equal to 100 minus 5, which is 95. B, we have a sub 1 will be 3 plus 1, which is 4. A sub 2 is going to be 6 plus 4, which is 10. A sub 3 is 9 plus 9, which is 18. A sub 4 is 12 plus 16, which is 28. And so a sub 100 is going to be equal to 300 plus 10,000, or 10,300. Now, if you look at these sequences, it's important to note kind of, the way they look. Negative 4, negative 3, negative 2, negative 1. Could you predict the next number to come after that? What would it be? It would be 0, and then 1, and so on and so forth, and up to 95, so on and so forth. And in this one, this is a little bit trickier, but we have 4, 10, 18, 28. Could you predict the next one? Goes up by how much? 6, then 8, then so 40, then 14, so 54, so on and so forth. Okay, and so you can see kind of the pattern that's generated there. If you notice, this one simply increases by 1 each time, doesn't it? This one increases, as you said, by 6, by 8, by 10, and by 12, and by 14. Well, it looks like these things both increase by 2, 2, 2, and 2, right? So you do see patterns that develop, and some of them are more intuitive than others. But sequences really, model what happens in everyday life, and we'll take a look at that in more depth as we move on. But let's look at sequences that aren't as intuitive to people. We look at a sub n is equal to 3n over n plus 4. So a sub 1 would be what? 3/5. A sub 2 would just be 1, right? A sub 3, 9/7. A sub 4, 12 over 8, or 3/2. So look at this sequence, okay? We have 3/5, we have 1, we have 9/7, we have 3/2. Could you look at that and predict what the next term would be? That would be really difficult, wouldn't it? So try to gain a little bit of appreciation. It would be easy for us to write a rule for the first sequence. It would be a little tougher, but still not too difficult for us to write a rule for the third or second sequence. But the third sequence, that would be remarkably challenging to go the other way, wouldn't it? Remarkably challenging. Very difficult to come up with that. We do know that a sub 100 is going to be 300 over 104, which if you divide by 2, you get 150 over 52, and divide that by 2, and you get 75 over 26. So that'll be the 100th term. What's different about letter D? N is in the in the exponent. So a sub 1 is equal to 2 to the negative 1. What's 2 to the negative 1? 1 half. A sub 2 would be 2 to the 0. What's 2 to the 0? And the 0 power is 1. A sub 3 is 2 to the first, which is 2. A sub 4 is 2 to the 2, which is 4. So you look at your sequence, you got 1 half, 1, 2, 4. Can you predict what the next term is going to be? 8. How'd you get that? Times by 2. What's the next one then? 16. And if you consider the 100th term, it would be 2 to the 98th would be the 100th term. See if you can produce the first 4 terms and the 100th term for letter E. Okay, try that out. I got 3, 9, 11, and 17. You see that? Can you predict what the next one's going to be? Looks like it goes up 6, then up 2. Then it goes up 6, then it'll go up 2, so 19. Then it'll go up 6, and then up 2. I mean, again, we could calculate the terms, but it would be challenging to go back to that one and figure out what that is. Yeah, very challenging. So you've actually seen some of this before, but we have what we call arithmetic sequences and geometric sequences. An arithmetic sequence is a sequence whose consecutive terms have a constant difference. That's an arithmetic sequence. Okay, so I'll give you an example. Okay, suppose we have -4 and then -1 and then 2 and then 5. Can anybody predict what the next term is going to be? 8. How'd you get that, Charlie? You're adding 3 each time, right? So you can see that each term has a constant difference. And so, you know, when you come up with an arithmetic sequence, you start with a first term, say a sub 1. And then the next term would be a sub 1 plus whatever the difference is. And then the next term would be a sub 1 plus 2 differences. And the next term would be a sub 1 plus 3 differences. And using that, we can generate a formula for the a sub nth term. And this is what we have, and this is an important piece for you to know. A sub n is equal to a sub 1 plus the difference times n minus 1. So remember I told you about how challenging it is to find rules for sequences. We've already done that pretty simply for these, okay? So find the nth term and the 20th term given the following. So a sub 1 is 5 and d is 3. So it says find the nth term and the 20th term. Well, we would like to have a rule. Find the nth term means find the rule. So a sub n is equal to a sub 1 plus the difference times n minus 1. So a sub n is equal to, what is a sub 1? 5. What's the difference? 3 times n minus 1. So a sub n is equal to 3n plus 2. Yes? So it says find the nth term, which is what this is, and now find the 20th term. So a sub 20, in order to find the 20th term, I simply plug in 20. 3 times 20 plus 2, or 62. What do you think? You think you can do a problem? You try letter B on your own. Okay, let's see what you got. You have a sub n would be equal to the 100th, or the first term, which is 100, minus 2 times n minus 1. And so a sub n is equal to negative 2n, and then we have plus 2, so plus 102. So a sub 20 is equal to negative 40 plus 102, which, what do you know? What do you get? 62. There's this strange thing that comes up with sequences, and that's this. The 20th term of any arithmetic sequence is always 62. We call it the rule of 62. Does anybody know why that is? It's actually a complete lie. I'm just making that up. So it just happened to be that they both came out to be 62. So anybody sense I was lying there a little bit, maybe? Do you question a little bit when I said, okay, this is the rule of 62? Have you heard of the rule of 72? Comes up with interest. Maybe you talked about it in your economics class or finance. Yeah, so anyway. I do that joke each year. It never gets old. So, okay. Here we go. That started because one time I had a student raise their hand in class. They're like, will it always be 62? And I was like, yes. Yes, it will. It will. The 20th term will always be 62. We just ran with it for about, a minute and a half, and then I couldn't handle it anymore. I started laughing. So, okay, good times. Glad I got your attention. Oh boy, what's different? Yeah, it gives you sequence. Shoot, if I only knew what a sub 1 was, what's a sub 1? Oh, I do know that. And if I only knew what the difference was, oh my gosh. What is it? 4. Oh, can I now write the sequence? Yeah, no big deal. So a sub n is equal to negative 3 plus the difference, which is 4. Times n minus 1. So a sub n is equal to 4n. It'll be a minus 7, it looks like. So can we find the 20th term? 4 times 20 is 80. 80 minus 7 is 73. So it's like the rule of 62 fails. Ooh, D is more challenging. I have a sub 1 is 20, but what's D? Anybody see what the difference is? What if I write this as 40 over 2, 39 over 2, 38 over 2, 37 over 2? Does that make it more clear than what D is? Negative 1/2. So therefore, a sub n is equal to 20 minus 1 over 2 times n minus 1. Where a sub n is equal to 20 minus 1/2 n plus 1/2. Where a sub n is, there's multiple ways to write this. I'll just go 20.5. We don't like decimals. This is like 40 over 2, so we get 41 over 2. 41 over 2 minus 1 over 2n, which is the same as 41 minus n all over 2. That's probably how they'd write it, I'm guessing, in the back of the book. Good? So, what makes something arithmetic? It has a what? Constant difference, yeah? So let's look at what makes something geometric. A sequence whose consecutive terms have a constant ratio. So you start with a term. We'll say that you start with 2. And then, well, the next one will be 6, and the next one will be 18. Anybody know what the next term is going to be? $54. Anybody know what the next term is going to be? $162. You know what I'm doing each time? Multiplying by 3. So you can see that you're multiplying by 3 each time. So instead of a difference, it's a ratio. It's a multiplier. And so therefore, as you produce the terms, you have the first term, then you have the first term times r, then you have the first term times r squared, you have the first term times r to the third, so on and so forth. So in order to produce a rule for a geometric sequence, you have a sub n is equal to the first term times r to the n minus 1 power. And it's really quite straightforward. A sub 1 is 2, r is 3. It says find the nth term of the following sequences. It doesn't say to find the 20th term, which it looks like I forgot to do for that top one. We sure could find the 20th term. What's 41 minus 20? 21 divided by 2. So we get 21 over 2 is going to be the a sub 20th term. So my bad for not following through with that, but I think we get it. Find the nth term of the following sequences. A sub n is simply equal to, we take 2 and we multiply it by 3 to the n minus 1. Can I take the 2 times the 3? To get 6? 6 to the n minus 1? Nope, totally illegal. Can't do that. But there are other ways to write it, okay? And I'm just going to show you one. Now, this is acceptable on your test, but I want to make sure that you understand where this can come from. Would you agree that that's the same as 3 to the n minus 1? Would you agree that that's the same as 3 to the n over 3 to the 1? 3 to the n minus 1 is 3 to the n over 3 to the 1. Same thing, right? So it looks like I could write this as a sub n is equal to 2/3 times 3 to the n. So 2/3 3 to the n is the same thing as 2 times 3 to the n minus 1. So sometimes people don't like the n minus 1. So this one I have a sub n is equal to 64 times 1/2 to the n minus 1. I'll write it without the n minus 1. I'll write it with the n. 64 times 1/2 to the n divided by what? A half. Well, dividing by a half is the same as multiplying by 2. So we have a sub n is equal to 128 times 1/2 to the nth power. What's different about letter C? Yeah, they give you the sequence. So a sub 1 is 1. What's my ratio in this situation? 3. So I have a sub n is equal to 1 times 3 to the n minus 1. Not too bad, huh? All done? The next one. A sub 1 is equal to negative 200. A sub n is, what? I'm sorry, not a sub n. R is, what's the ratio here? Anybody see the ratio? Negative 1/4. Very good. Because you're dividing by negative 4. So negative 1/4 is the ratio. So therefore we have a sub n is equal to negative 200 times negative 1/4 to the n minus 1. A sub 1 is 1. What's your ratio here? The root of 3. Would you agree the root of 3 is the same as 3 to the 1/2? So we have 1 times 3 to the 1/2 to the n minus 1. Well, if I have a power to a power, what do I do? Power to a power, what do I do with those powers? Multiply them, so I get 3 to the n minus 1 over 2. Last example. What's the first term? And can you tell what the ratio is? It's kind of difficult to look at it and determine what the ratio is, isn't it? So here's all you have to do. Just grab two consecutive terms and divide them. For example, if I had 2, 6, 18, 54, we said that if you take 54 divided by 18, you get 3, right? Or 18 divided by 6, you get 3. Or 6 divided by 2, you get 3. If you just take two consecutive terms and divide them, it should tell you. But you got to take like say the third term divided by the second term. You can't take the second divided by the third. So let's try that. 32 over 9 divided by negative 16 over 3. Well, how do I do that? Yeah, so times negative 3 over 16. And let's see, negative 3 over 9 would be a negative 1/3. And then 32 over 16 would be 2 over 1. So it looks like my ratio is negative 2/3. Kind of tough sometimes for people to see that. Did you see that right away, Kayla? Yeah. So if you look at the tops, you can see you're multiplying the numerators by negative 2, multiplying the denominators by 3. Okay. So I just want to show one example where you can always find a shirt. If you know it's geometric, or if you want to test if it's geometric, you can do that. Okay. But you should test each term, then each consecutive group in order to make sure it works out. Okay, so we have a sub 1, or a sub n is equal to a sub 1, which is 8 times negative 2/3 to the n minus 1, and that will be able to produce whatever term that you want. Okay? So, all we'll do is, on Wednesday then, we will cover what we call series. And series are super cool. They're really fun. And then after that, we cover recursive sequences, and that's it. I mean, that's all we have really left of this class, folks. And it's time for summer. So I know what you want. You want an assignment. Okay, for YouTube Nation, just looked up the assignment from last year, and I'll write it down. So it looks like we went 10.1, page 816, and we're going numbers 1 through 9 odd, and 10.2, page 822. There's 22 through 29, and then 10.3, page 830, numbers 23 through 27. There you go.